For this video, I will be discussing Math 9, Quarter 2, Weeks 1 to 2. So for Weeks 1 to 2 is all about variation. So let's go directly to the third paragraph. When two quantities increase at the same time or decrease at the same time, it shows direct variation. However, if one quantity increases and the other decreases, it shows inverse variation. You encounter such situations in your everyday life. For instance, if you walk slowly going to school, it takes longer time, but walking fast takes shorter time reaching the school. Your speed in walking varies inversely with the time. The faster you walk, the shorter the time it takes you to reach your destination. Another situation is when your mother asks you to buy rice, which costs 55 pesos a kilo. If 1 kilo costs 55 pesos, how much 10 kilos of rice cost? In this situation, the more kilos of rice, the more money you will pay. Hence, this is an example of direct variation. So let's discuss first direct variation. So in your previous lesson, you were able to represent relationship between two quantities using graphs, table of values, and equations. So you have there in your module, given table of values with x 1 to 5 and the values of y are 2, 4, 6, 8, and 10 respectively. So for the table of values, the equation is y equals 2x. So you can see from the table of values that as the value of x increases, the value of y also increases. The graph is a line that rises to the right. This is an illustration of a direct variation. This means that y varies directly as x. In symbol, y over x equals k, or y equals k times x, where k is the constant of variation or constant of proportionality. In this case, the constant of variation is 2. Number 2, you will be celebrating your 14th birthday and you want to have 14 balloons in your birthday party. The table below shows the number of balloons, x, and the corresponding cost, y. So for x, if we're going to have 2 balloons, the cost is 10. If 4, cost is 20. If 6, 30. And if you're going to have 14 balloons, then the cost will be 70. So as you can see, when the values of x increase, the values of y also increase. Hence, the cost of balloons varies directly to the number of balloons. So the more balloons you're going to buy, the more money you're going to pay for the balloons. Since y varies directly as x, find the constant of variation k. Y sub 1 over x sub 1 equals y sub 2 over x sub 2. So you're going to let here x sub 1, the first value of x, which is 2, and y sub 1, the first value of y, which is 10. And y sub 2 will be the second value of y, which is 20, and x sub 1 or x sub 2 will be the second value, which is 4. Then substituting that one to the given formula, y sub 1 over x sub 1 equals y sub 2 over x sub 2. So you're going to have 10, the value of y sub 1, over 2 x sub 1 equals 20 x sub 2 or y sub 2 over 4, which is the value of x sub 2. So if you're going to simplify this one, this is just equivalent to 5. 10 divided by 2 is 5, and also 20 divided by 4 equals 5. So the constant of variation k is 5, thus the equation of the direct variation is y equals 5x. Number 3, y varies directly as x. If y equals 12 when x equals 4, A, find the constant of variation. B, what is the equation? And C, what is x when y is equal to 36? So for the solution for the first one, A, finding the constant of variation, we're going to use the equation or formula k equals y over x. Then we're going to substitute the given values, y equals 12, this one, and x equals 4, so over 4. Then simplify 12 divided by 4, this is equal to 3. So the value of k is 3. Now for letter B, what is the equation? So the equation will be y equals k times x. Then since k is 3, so substitute k with 3. So the equation will be y equals 3x. Letter C, what is x when y is 36? So using the equation y equals 3x, we'll just substitute the given. So since y equals 36, so we're going to substitute here y with 36 on the left side of the equation. This one. Then equals 3 times x, or 3x. Then simplifying, we're going to divide both sides by 3. So 36 divided by 3 is 12. Then 3x divided by 3 is x. Therefore, we can say that x is equal to 12. Now let's go to the next one, direct square variation. Direct square variation states that if y varies directly to the square of x, there is a non-zero constant k such that y over x squared equals k, or y is equal to kx squared. The graph of direct square variation is quadratic in nature. It follows a quadratic curve. Now let's have examples. Number 1, y varies directly as the square of x. If y equals 27 when x equals 3, find x when y equals 81. So first we're going to find the constant of variation, k. So in here, in the given example, this one uses k equals y over x squared. Okay, this is the formula or the equation in finding the value of k using direct square variation. So what we're going to do is just substitute the given. So y here is 27, so we're going to substitute with 27. And for x, we're going to substitute with 3. So that is why in there, you have 27 over 3 squared. 3 squared is 9. So 27 divided by 9 equals 3. So the constant of variation here will be 3. So since 3 is the constant of variation, our resulting equation will be y equals 3x squared. Okay? The next question is, we're going to find x when y equals 81. So using the equation y equals 3x squared, we are going to find x. So what we're going to do is just substitute the given, which is y equals 81 in the equation y equals 3x squared. So y is equal to 81. So we're going to have on the left side 81 equals 3x squared. This one. Then divide both sides by 3. So 81 divided by 3. This is equal to 27. And 3x squared divided by 3 will be x squared. So you're going to have x squared equals 27. Then extracting the square roots of both sides. So square root of x squared, this is x. Then square root of 27, that will be 3 times the square root of 3. So 3 times square root of 3 from square root of 27, you can have that one as square root of 9 times 3. Okay, then square root of 9 is 3, so you're going to put 3 outside, so that is why the answer here is 3 times square root of 3. Number 2, if p varies directly as the square of q and P is equal to 256 when Q is equal to 8, find A, K, or the constant of variation, B, the equation, and letter C, P when Q is equal to 2 times square root of 3. So for the solution, we're going to find first the constant of variation, which is K. So we're going to use K is equal to P over Q squared. So given P is equal to 256, so substitute 256 over Q, which is 8. So over 8 squared. Okay. Then 8 squared is 64. So we're going to have 256 divided by 64, and that is equal to 4. Now since our K or constant of variation is 4, we can just substitute that one to P equals KQ squared to make the equation in letter B. So our equation will be P equals 4Q squared. Then letter C, finds P when Q is equal to 2 times square root of 3. So using the equation P equals 4Q squared, we're going to have P equals 4, then substitute 2 times square root of 3 for Q. So 2 times square root of 3 squared. So we're going to square first 2 times square root of 3. So 2 times square root of 3 times 2 times square root of 3, that will be 2 times 2, 4. Then square root of 3 times square root of 3 is 3. So 4 times 3, that will be 12. So 4 times 3 equals 12. So meaning 2 times square root of 3 squared is 12. So our result will be 4 times 12. And 4 times 12 is equal to 48. Next type of variation is inverse variation. In real life, there are different situations that shows inverse relation. Inverse variation states that y varies inversely as x, or y is inversely proportional to x if there is a non-zero constant k, such that y is equal to k over x, or x times y equals k. So indirect variation, that is y equals k times x, but in inverse, that is y equals k over x. So the decrease of one quantity results to the increase of the other quantity. Example number 1. The table below shows that number of persons working together, x, and the number of hours, y. The job is completed. Find the constant of variation and the equation. Graph the given table of values. So you have there the table for x. This is the number of persons working together. If number of persons working together is only one person, the time or the number of hours will be 2. If there are 2 persons, only 1 hour. If there are 3 persons, 2/3 of an hour. If there are 4 persons, then the job will be completed in 1/2 hour. And if there are 5 persons working together, the job will be done by 2/5 hour. So if we're going to have the constant of variation, you're going to use k equals x times y. If we're going to have the last pair, so for x, which is 5, and the y is 2/5, so 5 times 2/5, that will be 2. Same with the third one, 3 times 2/3, it is also equal to 2. Therefore, we can say that the constant of variation here is 2. So for the equation, that will be x times y equals 2, or y is equal to 2 over x. So if we're going to graph this one, this will be for x here, and this one is for y. So 1 for x, 2 for y, the first point here. Second, 2, 1, this one. then 3 2/3. This will be the third one, fourth, and the fifth point. Let's have number 2. If y varies inversely as, I think this is x, and y is equal to 20 when x is equal to 8, find A, constant of variation, B, variation equation, C, y when x equals 16. For letter A, constant of variation, we're going to use k is equal to x times y. So we're going to have x, which is 8. So 8 times the value of y, 20. So 8 times 20, so the constant of variation is 160. Then the equation of variation for letter B will just substitute the value of k, which is 160. So we're going to have the equation as x times y equals 160, or y equals 160 over x. Letter C, find y when x is equal to 16. So when x is equal to 16, we'll just use the equation y equals 160 over x. So substitute x with 16. So we're going to have y equals 160 over 16, and the answer will be 10. Number 3, the rate r of the car varies inversely with the time t. So the car travels at a rate of 60 kilometers per hour for 1.5 hours. Find the rate of the car when it took 1 hour to travel the same distance. So in this case, the faster the car travels, the shorter time it will take to cover the same distance. Hence, the constant of variation here is the distance. So using the formula for distance, d equals rate times time. So we're going to have 60. This is the rate times the number of hours, time, 1.5. So 60 times 1.5, that is equal to 90 kilometers. So this is the constant. This is the distance traveled by the car. So to solve for the rate, we're going to use R equals D over T. Okay? So substituting D, the constant, with 90 over 1 hour, the time traveled by the car. So the rate will be 90 kilometers per hour. This is when the car travel for 1 hour with the same distance. So let's have learning task number 1. So A, complete the table if y varies directly as x or x squared. So let's have the first one as an example. So y is equal to 30 if x is equal to 5. So we're going to find the constant of variation. So since constant of variation is y equals k times x, so we're going to substitute that one. So y equals k times x. So since y is 30 equals k, unknown, then x is 5, so k times 5. So we can have that one as 30 equals k times 5, divide both sides by 5. So 30 divided by 5 is 6. So our constant of variation here is 6. And if we're going to have the equation, that will be y equals 6x. Okay? That is for letter A. So just complete the table. So just do the next 3 columns. For letter B, complete the table if y varies inversely as x. So y here is equal to 5. X is 6. So we're going to find k. So again, we're going to have this one as an example. So for the inverse variation, we're going to use k equals x, y. Okay. So x is 5. So x is 6. So 6 times So 6 times y, which is 5. So 6 times 5. Therefore, our constant here is 30. So for the equation of variation, that will be x times y. I'll just put the equation here. X times y equals 30. Or you can have this one as y equals 30 over x. Okay, let's have the next one, joint and combined variation. So joint and combined variation involves three or more quantities that may vary directly and or inversely to each other. Let's have first joint variation. If the ratio of one quantity to the product of the other two quantities is constant, then they vary jointly. That is y, or that is if y varies jointly as x and z, then y over x times z equals k, or constant of variation. And you can also have that one as y equals k times x times z. So for example here, number 1, the surface area of a cylinder varies jointly as the radius and height. Area is equal to k r h, where a is the surface area, r is the radius, and h is the height of the cylinder. The constant variation is k equals 2 pi. Hence, a is equal to 2 pi r h. Any of the variable r or h increases, the area also increases. Okay? So this is for area or surface area of a cylinder. Number 2, translate the following into variation equation. P varies jointly as Q and R. So for equation, we can have that one as P equals K times Q times R. Letter B, area of a parallelogram varies jointly as its base and altitude. So equation will be A equals base, B, H for altitude, where K is equal to 1. So these are just examples of joint variation. Another example is number 3. If M varies jointly as P and Q and M is equal to 50, when P is equal to 5 and Q is equal to 2, find M when P is equal to 10 and Q equals 6. So for the solution, we're going to determine the constant of variation. So we're going to use here, this is not y over x times z, but M. This should be M over P times Q. P times Q equals K, or the constant of variation. Then substituting, M equals 50, so the numerator is 50 over P is 5, Q is 2, so 5 times 2. So 5 times 2 is 10, so we're going to have K equals 50 over 10, which is 5. Then using M equals K times P times Q, so substituting, so P in the given, the next given is P is equal to 10 and Q is equal to 6. So substitute K with 5, P with 10, and Q with 6. So 5 times 10 times 6. So 5 times 10 is 50 times 6, that will be 300. So as P and Q increase, M also increases. Next is combined variation. So this is a variation where one quantity varies directly to other quantity and inversely to the other quantity. So the equation V equals KW over X means that V varies directly as W and inversely as Z. This should be X. Varies inversely as X. So examples. Number 1. V varies inversely to X and directly to W. If V equals 12 when X equals 4 and W equals 8, find W when V equals 24 and X equals 2. So using V equals K times W over X, we're going to find first K. So what we're going to do is we'll just substitute the given. So for V in the given is 12. So substitute V with 12. Then equals K times W. W is 8. Okay. Then over the value of X, which is 4. Okay. So we're going to have K is equal to 12 times 4 over 8. 4 divided by 8, that will be 1/2. So we're going to have 12 divided by 2, which is equal to 6. So the value of K here is 6. So our equation will be V equals 6W over X. So the next question is find W when V equals 24 and X equals 2. So what we're going to do is substitute V with 24. Then we're going to have X with, this should be 2. Okay, so the given is not the same with the solution here. So I think in the given, this should be equal to 3. Okay, this should be 3. So let's just follow this one. So this should be 3. So if X is 3, so substitute with 3 here. So we're going to have 24 times 3 over 6 equals W. So 3 over 6 is 1/2. So the denominator will become 2. So 24 divided by 2 is equal to 12. Example number 2. If P varies directly as the square of Q and inversely as the square root of R, and P is equal to 20 when Q equals 2 and R equals 64, find P when Q is equal to 8 and R equals 144. So from the given, we're going to have the equation P equals KQ squared over square root of R. So solving for K, just substitute the given. So P is 20, so substitute P with 20 here. Q is 2, so we're going to have here 2K times 2 squared. Then R is 64, so denominator is square root of R, so square root of 64 here. Then, solving this one, 2 squared is 4. So we're going to have 20 equals K times 4. 20 equals K times 4 over square root of 64 is 8. Okay. Then simplifying this one, 4 over 8, this is 1/2. So this will become 2 here. So 2 times 20 equals 40. So the value of K is 40. So to solve for P, so find P when Q is equal to 8 and R equals 144. So we'll just use the equation P equals 40 Q squared over square root of R. Okay, since our constant K is 40. This one. So 8 squared is 64. Then square root of 144 is 12. So you're going to have there 40 times 64 over 12. So simplifying this one, 40 and over 12. So common here is 4. So 40 divided by 4 is 10. So this will become 10. And 12 will become 3. So 12 divided by 4 is 3. So 10 times 64 is 640. So 640 divided by 3 is our answer. So for learning task number 2, so just the same, supply the missing value if y varies jointly as x and z. So just use the given formula for joint variation. And for letter B, just use the formula for inverse variation. And you can get the answers. So just supply the missing values. Then learning task 3, identify if the given equation is a direct, inverse, joint, or combined variation with k as the constant of variation. So just apply what we have discussed a while ago. Letter B, write the equation of variation and solve for the constant of variation. So what you're going to do here is just apply what we have discussed a while ago. So that's it for this video. Thank you for watching and see you next time.